Hello. In the screencast, I will provide a quick introduction to one of the upcoming Spring Cloud Stream features, which is KafkaStream support. This is currently implemented as a separated binder that can be added to an application, but the goal is to have everything merged with the main Kafka binder. Let's take a quick look at one of our samples application, which is essentially the word count example from the reference documentation written using Spring Cloud Stream and Kafka Streams. The application uses an enable binding annotation and a special interface, which is in this case is called KStream processor. KStream processor declares as inputs and outputs Kafka streams. And the idea is that the framework, Spring Cloud Stream, will take care of connecting the inputs and outputs to their respective input and output topics, using the normal Spring Cloud Stream conversion for indirection and content type management, partitioning, and so on and so forth, in the destination and content type properties. And we'll actually see an example. The fact that the application supports that makes it possible, for example, for Kafka Streams applications to be orchestrated by Spring Cloud Dataflow, as you will see in the following example. Coming back to the application, once the inputs and outputs have been declared, the application can declare a number of stream listener methods, which essentially use those inputs and outputs to describe the business logic using the Kafka Streams DSL. So this is an example of, this is a very simple example, as I said, of the word count example to be found in the reference documentation. The method returns a stream of word count instances, and Spring Cloud Stream will ensure that these word counts are converted to the JSON representation as requested by this output content type statement in the application properties. As I said, the goal is to have the inputs and outputs observe all the properties or the standard properties of Spring Cloud Stream, or allowing the developer to focus on writing their business logic as described here. So let's start to build and run this application. First, I'm going to build the project. We're going to build the entire project, which includes the binder and the sample application. And the sample application is also installed in the local Maven repository. I already have the Spring Cloud Dataflow local server started, and I have registered the source, the HTTP source, and the file sync. So the next step is to register the Kafka Streams processor. I will register it as a processor, and I will use the Maven coordinates of the processor. Once the application has been registered, it can be used like any regular processor. So I can create a stream that connects the HTTP source and sends lines containing space-separated words to the KStream word processor, which will do a time window computation. Will basically count how many words, how many separate distinct words have been present in a specific time window, right? And this again is configurable, like through different properties, like essentially through normal Spring Boot properties. So the default being 5 seconds. We'll connect the 3 nodes into a stream, and also we'll set the port for HTTP source, and we'll set an output directory so that we can monitor. Right, and we're going to create a stream called HTTP file. deploy. Now we can send data. First and foremost, let's take a look at the 3 running applications. So you can see the file sync, the word count application, and the HTTP source having been started. And now we can start sending data to the HTTP endpoint, right? And we can also monitor it. Here, there is no file yet because no data has been received. So as soon as we send the data, we can actually see it over here. So you can see basically the JSON representation of each word count as well as with their start and ends timestamps for the windows, for the time windows in which those values have been computed. So sending values more rapidly, for example, gives you different numbers. You can also notice that for certain time windows, you get multiple values as soon as they get updated. This is because the method actually sends not only the final values, but will send updates according to configurable settings. So you can basically configure how frequently these settings, how frequently the values, the counts within a specific time window are sent as they change, right? But this is basically just an internal Kafka Streams feature. What is important to remember is that we have taken a piece of code, we have taken a Kafka Streams implementation, we have wrapped it into a Spring Cloud Stream application, and we have integrated it with a running stream using Spring Cloud Dataflow. That is all I have to show for today, and follow us for more news on this upcoming feature.